In this tutorial, we will demonstrate how to make a real-time transient recording of a circuit response and then compare the measurement results with the simulation using TINA and the TINA Lab 2 PC instrument. Note that the circuit is the same as the one used in our previous RLC tutorial, although now we have also measured and adjusted the capacitor and inductor values to produce an even better agreement between calculated and measured curves. Before beginning the transient recording, we need to modify a few settings. First, go to the Test and Measurement T and M menu and select Options. Uncheck the Generator Matching checkbox. This ensures that the oscilloscope will only begin recording once we start the function generator manually. Next, we place the instruments on the screen. We will now modify a few more settings. First, select the real-time function generator from the T and M menu. We place it on the screen, click on the square wave button, and check that the stop button is pressed. Next, select the real-time oscilloscope and place it below the function generator. On the trigger panel of the oscilloscope, we change the default auto trigger mode to single shot mode. In single shot mode, the measurement begins when we press the start button on the function generator. Now, press the run button on the oscilloscope. The oscilloscope is now active, but waiting for the trigger event, which is the first rising edge of the generator signal. Move the mouse over the function generator and press the start button. The measured transient response will appear on the oscilloscope screen. Now it shows both the initial response and later steady-state response of the circuit. Note that the normal or auto-triggering modes of the oscilloscope allow us to view the steady-state response only, since the initial response is overwritten by later periods of the signal. In order to compare our measurement result with the circuit simulation, let's export this curve into a diagram by pressing the Export Curves button in the data field of the oscilloscope. The measured circuit response will appear in TINA's diagram window. Now we will compare this measurement data with the simulation result. Let's temporarily close the diagram window and both instruments and run a transient analysis. Note that we have changed the transient maximum time step to 10 nanoseconds in order to enhance the accuracy of the simulation. Select Transient Analysis from the Analysis menu and press OK. The result of the transient analysis will appear. Of course, this result contains both the initial and the steady-state response of the circuit. Now we click the Measurement Result tab and change the color of the curve to green. Select and copy the curve to the clipboard. We switch to the Simulation Curve screen and paste the measurement curve. We see that the two curves overlap each other almost perfectly. By zooming in, we can observe small differences in the two graphs, but the general agreement demonstrates the accuracy of simulation and measurement in the TINA Lab 2 system. This concludes our demonstration comparing transient recordings with simulations in TINA.